Hi, and welcome to the first class of this tutorial. So you have downloaded the file from the website. It's called Class 1 Start, and you should have all these assets loaded in your HIP file. Now, the first thing you need to do when you start working on a shot is to be sure that you have all the assets you need and the camera, and the correct camera and the correct frame range. To do that, you can obviously scroll the timeline, but you can also make a flipbook, and I recommend doing this so you can actually check that the animation is not jumping, there's no problem. And this is what I've done for you here, so you can compare it to your flipbook. If it happens that you don't have anything loaded, be sure that you actually set the job properly. Okay, so you set your project properly because I'm using the job variable in the file. All right, so check that. You should have a frame range going from 1 to 150. The camera is looking upward to a truck coming in the scene. Now you need to check the scale of the scene. Okay, the scale of the scene is really important because Houdini engines assume that you are working with 1 unit equals 1 meter. If you want to check that, you go here into HIP files option, and you see that the unit for the lens is in meter, so 1 unit equals 1 meter. So to be sure that you have all your objects to the correct scale, usually what I do is I use a box or any other object that you know the scale of. If you have a character, you can use a character. And then I go here and I just take my box and I put it close to some other object in the scene. And for instance, here I'm going to use the truck. So I move back here, and now I have my box close to my truck. Okay, so the box is 1 meter high. It's a 1 unit for each side. And if I move the box, I see that I have like roughly three boxes for the truck, which means the truck is 3 meters high, which is a good scale for a truck. Okay, because a character would be 2 meters. It would fit there. You would really notice if the scale would not be correct. It happens generally when you come from another package, like for instance Maya. In Maya, the unit is 1 unit equals 1 centimeter. So when you bring everything from Maya inside Houdini, you would have something which is 100 times bigger. All right, so you would notice if it would not be correct. So yeah, that's it. This is a trick I use to check that my scene is at the correct scale. Now, next in line, you might want to check that you have enough pre-roll or enough space in your frame range to do your simulation. In my case, I don't really need a pre-roll because I have here the impact at frame 31, and I don't need anything emitting before. And if really I need, I already have like 30 frames, so that's okay. But if in your case you need a pre-roll, don't forget to prepare some pre-roll inside your timeline. Okay, so now we know we have everything we need inside the scene. Okay. The first thing I like to do is to do a little bit of cleanup. Why do I do cleanup? Okay, so the first reason could be that we got some geometries that is still a little bit messy, and we want to clean that. But the real reason is that I want to avoid loading into the memory, into the scene, any information that would be useless for the simulation. Because if I do that, it's going to be cluttering the memory, and all this space in the memory is not going to be free for the simulation. Okay, so I'm going to go inside the track here, okay, the first object. The first thing I notice is really the track is static for most of the timeline, okay, starting from frame 50, it gets static, okay? So I might be able to do something about it. The other thing you can notice is if you middle click here that you have some attributes and groups that are completely useless for us. Like for instance, these groups here, this might be leftover from the modeling, and I don't need that for the simulation. Same goes with the gas, the UV. I won't need the UVs for the simulation. So I'm going to delete these guys. Let's put a group delete, okay? And on this group delete, I'm going to say delete everything. The star is a wildcard for delete everything, okay? So catches everything. And then here I'm going to put an attribute delete, And same for the attribute delete. I'm going to say, well, on the vertex attribute, remember there was a UV. So I'm going to delete everything. And here I'm going to say delete everything except, and for except, it's another wildcard, which is the caret, except for V. So you delete everything except for V. And now you notice that it got rid of all the groups here. Okay, now we don't have any more groups. And here, it deleted all the attributes except for V and P. P, you don't need to tell it. Okay, you don't need to mention it because it's obvious that we still need the position of the points. So P is never deleted here. All right. Then lay down a rob geometry output there, and we are going to write this geometry to disk. So frame range, we said that we don't want more than 50 frames. Okay. And then here I'm going to put that into the animated folder at the same level as the truck, but into a new folder. I'm going to call that truck geometry. Okay, can you copy that because I'm lazy and I want my file name, my file sequence to have the same name as my folder. So then I want a padding of 4 digit for the frames, and then bgo.sc. Okay, then I save that. This is what I got. Okay, I can check the path is correct. One last thing here, you want to change that to job. Okay, and there I can save to disk. Okay, it's been fast. Then if I go here inside the Houdini Geo animated, then I have my truck geometry. And you already can see here that we saved a lot of disk space. Okay, so this is on disk. All right, it's not in memory, obviously, but we already can see that we are helping ourselves a lot. Why? Because all this information, it's that much information that we are not going to pull from the disk. So we save on the reading time. And also, because the disk, most of the time when you're working in production, they're on the network, then it's that much time you save from loading from the network. And so you save some bandwidth as well. Okay, so from 90 megabytes here, I go down to 12 megabytes. Okay, so your colleagues are going to thank you. And if we all work like this, then we might save a lot of disk space and bandwidth while we're working. Okay, so I'm going now to read it back in. Yeah, because I want to check that everything is fine. Because I don't want to bother copy pasting and writing the same name all the time, then I'm going to copy the parameter here and paste the relative reference. Okay, so I check, it's fine. It's actually reading the file and it's erroring after frame 50, obviously because we don't have anything cached. So what I'm going to do now is put just behind it a little time warp, because I don't want to keep some error message in there, because if I use that as a collider, if I use the track as a collider or as an emitter, it might be bothering the simulation. So just in case, I use a time warp. The time warp usually is used for retime, but I don't want to retime anything here. I'm fine with the timing. So I'm going to give the same frame range for the input and the output. So you're not going to retime anything. You have the same timing, but I'm using this post hold function here from the retime node, so that it's freezing my animation after frame 50, and then I don't have any more error. Okay, so it's a little trick. If you want to check that it's actually working fine, you can look at the original, or this even here, and see that it's actually not moving compared to the original one. Okay, so it's all static. All right, and then to finish here, I'm going to lay down an out node. Okay, so this out node is basically a null that I preset. You don't have this by default. It's a preset that I created here for myself. If you want to do that, you can do this. Okay, for anything, you can do that. Example, for instance, I'm going to give it a color of yellow, and you drag and drop it here. So if you click, you can have as many as you want. All right. So you can do that, and obviously you can also call it from here. All right, so just for you, there we go. All right, so I have this, and now there's one last thing, yes, I want to do, sorry. I want to optimize the naming. Not really optimize, sorry. I want to make this naming procedural. Okay, I want to, because I'm going to reuse this setup for the other objects. So I'm going to try and use the name from the parent object here and use the name from this node here inside here. So to get the name of the parent, it's truck. So there's a function which is called upName. Okay, this function, to be able to use it inside a parameter, you need to use the backtick here, okay? Not the quote, not this one, not this one, the double quote. You need to use the backtick, all right? And the upName, I'm going to say, okay, go get the name of my parent. And to get the name of the parent inside here, inside the quote, you give the 2 dots. The dot is like for Linux. It's go to my parent folder, and it's going to use the truck here. So if I do that, then I see that I still have the truck, even though I used the upName here. And then I'm going to replace this. I want to use the name of my operator here. So not the parent. This time I want to use myself, I mean this node. So I'm going to do the same, upName, okay? And instead of going 2 dots, which is my parent, I'm going to use 1 dot. And it's going to use rob geometry. Obviously, I did not cache anything at rob geometry. I cached something at geometry. And now I have the name, which is correct here. Another thing you can use instead of the upName is the $OS. You might know about this. OS for operator string, or at least that's what I guessed. And now we still have this truck geometry, and I'm going to use that also here. Okay, there we go. So I have my naming correct, and maybe I'm going to put some color as well, just because I know I'm going to do some flipbooks, and I want to see the truck correctly. So I'm going to put this there. Lay down this because of my OCD. I want to clean this up a bit. Oh yeah. So instead of overwriting my start file, I'm going to save that as weep. There we go. Okay. And now if I go here, I see that my truck is black and it's playing correctly inside the timeline. The next one I want to work with is the wall simulation. We see that the 2 statics one are quite easy to do. It's just the same as the truck. The wall simulation has some specificities. So if I dive in there, I can see that by playing my timeline, that some of the fragments are actually caught up here and behind, if you look at it, they are behind the terrain, okay? So it might be that the previous artist working on the shot and doing all the rigid body simulation didn't have time to clean it up, and it was approved and it passed it to me because it had so much to do. So fine, I'm going to clean it myself. So why do I really need to clean it? Because it's below the terrain, and we say, who cares? Well, because if I select all this, this wall simulation as an emitter inside my simulation, then it's going to emit some dust below the terrain. And it's going to be a pain to manage and to deal with it. So it's better to start with something clean. So go here, zoom to your object, press S to go into selection mode, okay? And go here and select the name attribute. That way it's going to select geometry. Even if you select only half of it, it's going to select everything, okay? So that way I'm sure that I'm actually selecting all the primitives belonging to the geometry, to the chunks, okay? So that's what I have now. And then I press tab inside the viewport, see, and I type blast. And then the blast is automatically created with all the names of the name of the chunk that are going to be deleted. And if I press play now again, this is what I have. All right, cool. So I go back to my camera mode. Great. And now, well, the next thing I want to do is clean up the group attribute, the group names and the attributes. And I'm lazy, so I go here and I'm going to copy paste all I did before. Going to wall sim, and I'm pasting this. All right. Okay, so I do that. Now I'm blasting. Okay, so no more of the geometry. Then I'm deleting the groups. And now here on the attribute delete, then I need to do a bit of adjustments. Here, the detail, I can delete it because I don't need that. Then the primitive attribute here, name. Okay, this one I will keep it because I want to have a way to identify and isolate each of the fragments. Why do I need that? It's because I plan later on to do some densities that is varying per fragment, okay, to add a bit of variation inside the simulation. So I need a way to identify them. So I'm going to keep the name here. And for the point attributes, I think I deleted too much of them because I still need the normal, at least for my fragments. I will need the normal of my fragments to do some little tricks later during the emission. I don't need the orient nor the pivot. W, I'm not sure. I'm not going to write it right now. And if I need it, then I come back here and write it. So really, I need to exclude the normal from being deleted. Okay, and this is what I have now. Good. So now I have this. I'm going to save my file, geometry. Now I'm going to cache that. What should I cache? Well, if we look at the actual simulation here, we see that the wall is static before the impact, which is frame 31 here. So anything before frame 31 is useless to me. So I'm going to cache only starting from frame 31, and I need to cache up till the end of the shot, which is 150. Now let's check this expression. Okay, it's going to write into wall sim geometry. Okay, wall sim geometry, and same, the file name is going to be wall sim geometry. This is the beauty of the expression. Now you just copy paste and you don't have much to change here. Okay, and because this one referenced this, then you don't have to write it again. Okay, so you save some time. I save the file. I'm going to save to disk. Okay, so it's going to write it. It's pretty fast, so that's good. And now I have my file here. I press play. I don't have anything up until frame 31, and then I have something playing. Okay, just to be sure, hide other objects. What did I do? Ah, sorry, it was just a selection. Okay, so now I have only what I need inside this geometry. Now, obviously, I don't want the error, so I'm going to go for the time warp here. And same as before, I need to tweak this. So obviously, I need to go up to the end of the shot. Okay, so here I'm going to the end of the shot. And then I need to say, okay, my output frame range is going to be 1 to 150, but really it starts only at 31. So now, okay, maybe I mixed. Now this is retiming. Oh yeah, because I need to. It's basically the same as before. It's not. I don't want to retime, so I'm using the same in and out. It's just that I'm using the pre-hold this time to hold the geometry up until frame 31. Okay, sorry for the confusion. And I want to color that. I'm going to color that with some brownish value, something like that. Yeah, it's a bit too red, too green maybe. I need a bit of blue in there. Yeah, something like that. Yeah, I'm cheating. I know the values. Okay, so I have this and I have my object now. It's all cached. Let's check the cache actually is good. So we have 66 megabytes instead of 96 here. So we saved a sort of space, sort of the disk space by deleting this part and also by deleting some of the information that was cached on the geometry. All right. Now I am going to clean up the terrain here because there's a lot of information that we can trim from this geometry. As you can see, I mean, the impact is going to happen here around this area, and we don't need all this part. So for that, I propose that we create a box here, okay, that I'm going to call bounds. which well, I call that bounds because they are going to be the boundary for my simulation as well. We don't need anything else beyond the bounds. Okay, so as before, I'm going to take this and move it to where I need it. All right, so put this box here. Now it's closer. Okay, maybe what I can do now is just increase the box. There we go. Okay, it's too slow, so scale 10, 20, 10 and see how it goes. Now here, I might have to increase that. Okay, so I'm going to place it roughly where I need it. Okay, increase that in maybe in X. I think I need it a bit more, maybe a little bit more in Z as well. Okay, so I put it, I set it really large, just to be sure that I get everything I need in there. Okay, I want that to be higher, so maybe I'm going to put 22. Okay, and this is what I have now. And this box here, okay, that I have, I'm going to import it inside my terrain. Okay, so merge it. Object merge is the keyword. I'm going to merge my bounds. Okay, and because I don't see it here, as you can see, I want to see my box here. So I'm going to say merge into this object. So it's going to combine the transformation of this one with the transformation of this one, which is here, okay, to actually import it correctly. And now I have it here. And if I do a Boolean of this guy and this guy, and by default it's set to intersect, and it's going to intersect it correctly. This is what I want. So there's nothing else to do. I'm just going to put out node here. Okay, so it's clean. Nice. And I'm going to do the same for the wall static here, because really I don't want the part outside of the bounds. Okay, so I'm going to do the same here. And what I suggest is, because it's really the same operation I'm going to do, and then I'm going to use the group delete and the attribute delete and cache again. I'm going to pause the video, prepare the scene for you, and I come back with it and I will comment it in case I do something a little different. And then we are going to use this one for class 2. Okay, so here is the file that I created for you and that we are going to use for class 2. I didn't change much, but we are going through this. Here for the truck, I basically added just a display and a render flag, which are the same in this case. For the wall static, dive in there. I did like for the terrain, I did the same thing. I used the Boolean and then deleted the attribute, the groups, and cached that. I also added some render flag here and a display flag so that we can do some flipbooks correctly. The wall simulation, same thing here. I added some render and some display flag. There's one thing else I did is I fixed the normals, because if we go into the geometry here and if I display the normals, here, this is what we had and this is now what we have. I think it's a bit clearer, a bit more clean, so I wanted to add this, and I added the normals to the points, so we have it here as an attribute. Okay. Then what else? The terrain, same thing. I did some display and render, and then the rest cache. Oh, I forgot to mention, in the static parts, which is the terrain and the wall static, I changed the expression here so that it goes into the static folder. And obviously it's not really the same expression because I don't need a subfolder in there. So I just use this part of the expression. Okay, same goes for the terrain. Just change the expression there. All right, and the debris, I left them as they were because I mean, it's not much data, so it won't clutter too much the disk. Then I also added 2 lights, materials in the material network, and a ROP network with the ROP, so you can start rendering your background. Okay, here. And that's it. So that's the file we are going to use for class 2. If there's anything to remember from this class is that you need to prepare your geometry, you need to prepare your asset, not only to double check that you have everything that you need, like the camera, the frame range, the geometry, and that the scale is correct, but you also need to clean up a bit your geometry to save some data and to save some disk space and bandwidth, okay? And the more you clean, the faster you get, the faster your workflow will be, the less data you will have in memory, and the more you will have saved for your simulation later on. Okay, well, that concludes this class 1, and well, I'll see you in a bit for class 2. Goodbye.